All right. So we have already figured out what my name is and what I'm supposed to do, but let me give you a little bit more of my background just to give you a context where I'm coming from and why I'm interested in that topic. I'm what I would say usually a data engineer turned cloud native engineer. So started out some 20 odd years ago, worked in research and then moved to industry. If anyone was around in the heydays of Hadoop might remember MapR, and then moved to containers, and now I'm at AWS. I'm what I would call open source and community first, so contributed to projects in Apache Software Foundation and nowadays in the Cloud Native Computing Foundation, which is a Linux foundation that originally was founded to host Kubernetes and now has many, many more projects. And as I said, or as I already mentioned, I like to write code and books. So both have their pros and cons, but both of them are pretty much already outdated when they hit the respective location. And please do get in touch. I'm on Twitter, not sure how long, but for now I'm on Twitter, LinkedIn or whatever. And I'm really interested in hearing what you think about that topic. And if you have any suggestions, this is really as much of a giving you an idea of what observability is as if you have a data engineering background or interest, how could you help us solve these issues? Sound good? All right. So this is not a technical glitch. This is actually the first slide. Imagine yourself, you're sitting in the cockpit of a plane and you're the pilot and you have this view, right? And now compare it with this view. Which one would you prefer given that you're about to land, for example? I suppose most of the people in the room would prefer that view. And why is that so? Well, you have a lot of things going on here, obviously, but you also have a lot of insights and a lot of data coming at you that you can use to make decisions. Should I go up, go down, slower, faster, whatever? Now let's map that basic idea of what observability means to a concrete example. And nowadays, we still have a lot of monoliths, and that's a good thing. I'm not saying everyone should be doing microservices. But if you look at a monolith, for example, an e-commerce application, you have certain modules in there, right? You have parts that do some stock management and fraud detection and ads and whatnot. And they are interfacing with some external services or APIs as well. And if you have done a good job in modularizing your monolith, then it's pretty straightforward to break that up into microservices, right? Now, all these different modules that used to be in your monolith are running as separate microservices somewhere, for example, in a Kubernetes cluster. Obviously, in terms of feature velocity, if you think about introducing a new feature or a bug fix in one of the microservices, you are now faster. You can more quickly deliver new features because you're not dependent on other parts of your application. Necessarily, you also end up with a polyglot system, meaning that both the programming languages and the data stores now typically are not necessarily all the same. So you might have some things written in Java, some written in Python, in PHP, and so on. And also the data stores, you pick for what is good for this respective workload, for example, a key value store or a relational database or whatever. And you also gain partial high availability for the overall app, meaning that it might be that one of those microservices you just update or is down or whatever, well, you might not get ads served, but you can still check out stuff. So that's awesome. Seldomly nowadays with microservices that you see that the entire application is unresponsive. However, there are also some downsides to that. We are now dealing with a distributed system, right? It's not this one thing that runs in a particular place, but it is many, many different things that need to communicate over the network typically. It's more complex. And last but not least, for our conversation here, observability in this case is not an option anymore. It is a requirement. Otherwise, you're literally flying blind. And that ties us back with the initial analogy that I tried to make. You're flying blind. You don't even know where to look in your overall microservice setup. And that's a very simple one. You might end up with 200 or more microservices there. So what is observability? If you want to, you can just read that. We're going to work through that just to make sure. At the end of the day, we have this feedback loop, right? We have some sources, that's your workload, that's your databases, whatever. And then you have, on the one hand, software, on the other hand, humans that need insight to make decisions to change something there. That's very, very abstract. So let's have a closer look at what we mean. Before we get to the how, we first have to quickly review the different signal types that we are dealing with here. I've ordered them from most widely adopted to least widely adopted. So logs, I'm pretty sure everyone is familiar with logs, right? Is anyone in the audience who has never heard about logs? Okay, cool. Essentially textual payload and usually humans consuming those logs. Metrics are numerical signals, and there you typically, you measure something like, the throughput or the number of requests per second or whatever. And very often, that's why I use this visualization here, you have some kind of dashboarding going on. You see, where, in this case, this is a HTTP request by different HTTP response code, where you see, okay, what is going on? Green means 200, and so on and so forth. So how is the distribution going? Traces are about, if you have a microservice setup, you have essentially a request that is serviced by many, many different microservices. And that means that rather than in the case of the monolith, where you have all your context in one place, you now have the execution context in many different places, and traces, in a sense, binds that together. So it looks essentially at an ID that you need to ingest in the beginning and passes that on across the microservices, and then takes that information and stitches it together. And the usual rendering is kind of this, and you can pretty quickly see where in your microservices along the request path most of the time is spent. Last but not least, profiles, which is relatively new, specifically in the open source world. And that is all about being able to pinpoint the exact execution within the code. So you would be able to say, in this function, so much memory or CPU is used. And all of them have their use cases, and all of them are valid. So now that we have the signals defined, let's work our way up from the bottom of our pipeline. The sources, as I said, can be really anything. It might be code that you own, you put into a Lambda function, and you run. It might be some pods that run in a Kubernetes cluster. It might be your database that emits metrics or logs. It might be VPC flow logs. It might be coming from network. Whatever it is, it's a wide array of things that produce signals. That's probably the easiest way to describe it. Then you've got the agent. That's the thing that takes the signals from the sources and delivers them to the destinations. We'll get back to that, why this is important, but it's part of that setup. And I suppose you probably have come across things like you might have seen FluentBit or the CloudWatch agent, or there are many, many different agents out there. I picked one that is pretty much the future, the OpenTelemetry project, in this case, our distribution. And then there are the destinations. And this is probably where many of you, if you have a database, data store background, have a lot of experience. That is, on the one hand, you have backend destinations, time series data stores, etc. On the one hand. On the other hand, you have front-end destinations like Grafana, for example, where you can actually visualize your signals, correlate them, query them, and filter them. So that's essentially the pipeline that we're building up here. And everything in between, so the exposing, collecting, and routing. Exposing includes the instrumentation that you might do in your own code. So essentially say like, okay, emit this log line here, or emit this metric there. or a span in case of tracing. So agent plus that instrumentation, that is the telemetry, getting the signals from the sources to the destination. And if you already now try to map what I'm telling you here with what you know from data pipelines, you will probably come to a very similar conclusion as I will in a few minutes. So humans, again, there are many, many different roles if you think about developers, operation folks, etc., and different tasks where signals come in handy or are necessary, otherwise you don't really know where to look and what to do. Troubleshooting, the typical one, performance optimization, specifically around profiling, debugging, testing, and so forth, just a few examples. Software, on the other hand, typically you obviously want to automate things, and the obvious solutions there in the destination space are things like outlier detection. You want to know, what is the normal state and what is an outlier. But there are also other application areas like autoscaling. If you think of a number of pods in Kubernetes or a number of virtual machines, and you define if a certain metrics, let's say the CPU utilization, goes above a certain threshold, then scale up at some VMs and the other way around as well. So that would be software consuming these signals to automate some tasks. And if you're very fancy, then you don't just have an autoscaler or whatever, but you have machine learning, right? You have something that goes beyond the pre-programmed, okay, if above this threshold, then add one VM. But in most of the cases, we are still in our space relatively early days. So machine learning is there. We have certain application areas, but specifically around open source, not that much yet. So coming back to the definition, I hope now it's clear what this feedback loop means. What we really want to do is to continuously generate and discover actionable insights. And that is also what sets observability apart from monitoring. In monitoring, we're also doing, essentially the same setup, but we know exactly what we're looking for. We know beforehand, okay, I don't know, the threshold for CPU is 80%. And then we can alert on that. We can say, if it goes above 80%, send out an alert, pages me, I go to a dashboard, have a look at it, and so on. Whereas observability, I don't even know what questions to ask, right? I don't know which of the microservices might be, where in the code it might be. So I need to use a combination of different signal types to get to these actionable insights. And that's the key point. I want to have actionable insights. I need to say, okay, restart this microservice, or roll back this other microservice. All right. Before we get to the challenges, I thought it might be useful to review a few open source projects and specifications, just to give you an idea where we are currently in terms of coverage, and where, again, look at it from your point of view as a data engineer, you have an opportunity to contribute maybe. So we have a lot of things going on in the logging and log routing area, Elasticsearch, OpenSearch, there's Grafana Low-Key, there's FluentD and FluentBit, just a few examples there, many, many more. And logging has a little bit of a challenge because on the one hand, you have many different formats. On the other hand, you don't really have a standard. OpenTelemetry, in the fullness of time, later this year, beginning of next year, might be that standard that also covers logs. Currently, it covers traces in GA and metrics coming up in GA soon, but logs are still work in progress. Metrics and monitoring, there are a couple of wonderful projects from the CNCF ecosystem. Prometheus is, I think, relatively well known. Let me actually check. Who has heard about Prometheus? Nice. Okay. So Prometheus is essentially the idea that you expose certain signals in either your own code or through an exporter somewhere else. And then the Prometheus server goes and essentially calls these APIs and collects the metrics there. And Because of the design of Prometheus, which was always meant to be, for a single, vertical scale, not sharding or whatever. We have a couple of projects like Cortex and Thanos that allow us to do long-term storage, that allow us to do federation of queries. If you think about, you might have multiple Kubernetes clusters or whatever you have, and you have multiple Prometheus bringing metrics together in a central place. You want to be able to deduplicate, you want to be able to query in one central place rather than query all of these Prometheus instances and bring that together yourself. So Cortex and Thanos address this long-term storage or federation use case. Distributed tracing is, again, from the open source perspective, relatively new. And there are projects, specifically Jaeger, being very widely used and popular there. And I would say in terms of uptake, again, it's in the order of uptake. Like everyone is using, emitting, whatever, the logs. Many people nowadays already doing metrics. Distributed tracing is still relatively new. There are use cases, there are folks who are doing it, but compared to metrics and logs, probably not that widely used. Continuous profiling is even newer, but again, good news. We have a lot of momentum there in the open source space. There's Parker, there's Pyroscope, there's Pixie, which is a CNCF project. And all of them essentially allow you to do the profiling, the continuous profiling, meaning you every, let's say, second or whatever you choose, you essentially create a profile and then collect that, and you can essentially query in a central place how is your application performance going, memory, CPU consumption, and then can actually figure out what line in the source code caused a certain change there. But again, very, very early days, but certainly something that is super important, not just for the traditional use case that used to be application performance monitoring, but really for many others, including troubleshooting and debugging. Moving on to a project that you can more or less think of a single pane of glass. So Grafana is essentially able to read data from various data sources. There are many, many data sources out there. In this case, the upper one, the logs, come from CloudWatch, the middle one comes from Prometheus, and the bottom one, the traces, come from X-Ray. And you can visualize, you can correlate, you can filter, and it's a pretty straightforward way to bring in signals, different signals from different data sources in a central place. And last but not least, mentioned already earlier on, OpenTelemetry. So OpenTelemetry has a little bit of a strange background or history. It originally came out of a merger of two CNCF projects that were both focusing on distributed tracing. And then the OpenTelemetry project decided to broaden their scope to not just focus on distributed traces, but also capture metrics and logs. So that's why the traces are already in GA, meaning that both the SDKs for 11 programming languages and the so-called collector, that's the agent bit in the middle, are in GA for traces. We're working on the metrics that should be GA ready in the next 2 or 3 weeks. And logs are still work in progress, which, if you think about it, is a little bit weird because that's exactly the opposite of where you see the general adoption, right? Because, as I said, everyone is using logs, most people are using metrics, and not that many people yet using traces. But that's where we are. That's just to give you an idea how a collector looks inside. There are pipelines, there are receivers and processors and exporter, and you can essentially define pipelines. You can say, well, for metrics, I want to get metrics from these different sources, and I want to send them to these different backends, and that's essentially just a configuration change. So think of it of an OpenTelemetry collector as a kind of universal agent, being able to collect and route any kind of signal, which is, as I said, currently true for traces, metrics, logs coming up soon. You can already use it, but not in production. It's very experimental. And next up are profiles. Hopefully there is an enhancement proposal. Let's see how fast we get to that. All right. Now let's switch to the observability challenges. In this section, I'd like to ask you to keep an open mind and map what you know from your experience in the data engineering field and map that with the respective challenge that you see there. Maybe you already see the one or other thing that is kind of obvious. Already mentioned early on, we have a bit of a challenge with the telemetry agents. There are traditionally many different agents because it was kind of like based on the signal type or based on the back end. The hope is, as I said there with OpenTelemetry, that there's a standardization. There's the instrumentation of apps. So if you own some code, so I'm not talking about a service that you're consuming, like a database or whatever, but really your own code, then if you do not instrument it, if you do not insert actual code that exposes certain signals, then, well, there can't be any signals that can be collected. So there is a cost to that. The challenge with cloud-native systems, and that is a very wide area, right? That can be function as a service, that can be things like Google Cloud Run, that can be Kubernetes cluster, could be something like EKS on Fargate. Doesn't really matter the actual unit or the actual environment or orchestrator, but there is a general idea of you have something that is highly dynamic, you have small units, so the absolute contrast to a monolith being deployed on a bare metal or virtual machine that is probably updated every half a year or whatever. So that's in general cloud-native systems that are highly dynamic and small units, where a unit, as I said, could be a container or a function, for example. In terms of the storage and also managing the storage, there is this challenge of finding the right retention period for respective signals and their usage, which means on the one hand, you might have regulatory requirements or business requirements why you want to keep logs, for example, or whatever signals you have around for a longer time, right? You might, in order to be, PCI DSS compliant, you might keep certain logs around for a couple of years. On the other hand, that's obviously cost, right? If you store logs or traces or whatever for a long time, years, and you have high volume, you can imagine that means costs. Right? So you need to balance that. What is the right period? Are people familiar with the idea of data temperature? No? Okay. So I first came across that back then in the Hadoop days. That's basically the idea that you're looking at how important is the data to you. So if you have something that you need, in seconds, milliseconds, you want to have fresh data that you can query, then that's hot data. If you have something where you're happy with waiting for tens of seconds, that might be warm data. If you have data where, for example, think of the regulatory use case where an auditor comes along and says, show me the logs from this customer 2 years ago. And you say, well, that takes me 10 minutes. That's fine. That's cold data. And depending on the temperature of the data, you would assign storage classes that are more or less expensive, right? So the hot data would be in a storage class or storage system that is expensive, but you would only keep, the last day or the last week or whatever. Whereas the cold data is in a storage place that is typically supposed to be very cheap, but that comes with the access time being obviously very high. But that's fine for certain use cases, certain types of data. I already mentioned that in the context of instrumentation and agents as well, and that is you want to minimize the vendor or feature login, right? So if you think of instrumenting a code with a particular library of a vendor, and then you want to switch the backend, you want to say, well, I don't want to send my data to this vendor anymore, I want to send it to somewhere else. Do I now have to re-instrument my code? And the answer is hopefully no. We are not there yet, I would argue. Then there's always the buy versus build, right? Should I outsource that? Should I just use a service from a cloud provider or a vendor? Or should I build it myself? Should I own it myself? There is no great answer to that, but my belief is that open source and open standards allow you to essentially, you can start out building it yourself, and when you feel comfortable, you can use someone else's offerings, but you're not locked in because you're building it on open standards, so you can move to another vendor without being locked in. I mentioned already earlier monitoring. Many people go like, yeah, observability, that's just hipster monitoring, right? What's the point? I hope I made it clear what the difference is. As I said, again, monitoring being this, we know what kind of questions to ask beforehand, whereas observability, we are discovering things as we go along. And this transition, you see it quite often, vendors, projects and so on that have been around for a long time. It's tempting to just slap on the observability label, right? We used to do monitoring, now we're doing observability, that's it. Turns out that's not really the case, right? So you need to have certain things in your offering that really make it an observability solution. Many customers want a single pane of glass, saying like, okay, I want one UI or one app or whatever, where I can see all my different data sources, all my different signal types together. And that's hard, right? Because as wherever, acquisitions or whatever it is, you always end up with usually multiple single panes of glass. But still there is this desire there. There is the problem of signal hoarding, and that is very often that might have different reasons. That might be not being familiar with the signals, that might be unsure what the use cases are. It's essentially this idea, let's just ingest everything and then figure out later and prune it once we have it in the destination. And that can be a very costly thing, right? Because once you have it there, you're already paying for it. So the question is, can we be smart about it? Can we be selective? And the idea is working backwards from what you're actually needing, right? So if you don't, for example, graph a metric in a dashboard or alert on it, do you really need that metric? There might be good reasons why you want to keep it, but this kind of, let's just ingest everything we have and figure out later if we need it or not, can be a big problem. And last but not least, correlation of signals. By that I mean that you have one signal type. Imagine this use case where I get paged, I look at a Grafana dashboard, for example, where I see a certain metric. So it's like, oh, that's strange. Can I see the respective trace or spans from that service in this time range, right? So in a system where I don't have support for correlation, I need to kind of figure out manually, okay, this was the time frame, what is the service? I need to go to this other distributed tracing front end and figure out what are the right traces. In a system that actually supports correlation, I can just click on it, right? And there's actually for this specific use case metrics to traces. Thankfully, there's already a proposed standard or specification really called exemplars that allow you to do that. So you essentially can click on a metric, on a point usually somewhere, and it directly connects you to the respective trace. But that's not true for all different combinations of signal types. All right. So if we step back a little bit, putting up the data engineering hat, and look at various characteristics there, I tried to come up with a kind of rating, like how relevant is it, how big of a problem or surface is there, and then what the actual focus or what the background there is. So let's work through that. Data acquisition, because we're mostly dealing with machine data, right? All the data that comes there, logs, metric, traces, and so on, that's machine generated, right? So in contrast to many other data engineering places where you have data that is generated by humans, think of, I don't know, an Excel sheet or a Word document or whatever, where humans enter something, we mostly deal with machine data. Which means the data acquisition, yeah, it is an issue, but it's not our biggest issue. In terms of cleaning the data wrangling, yes, there are certain areas. If you think, for example, about sampling in the case of distributed tracing, that's certainly an issue, or it's a topic, but it's also not a very complicated or a very pressing one. So yes, we are using, specifically in the agent, sometimes already in the source, certain features, certain algorithms to downsample, for example, or transform. For example, the canonical use case is you have one format coming in and you want to store it in a different one, right? You have one specific log format and you want to store it in a different one, for example. But it's relatively scoped and easy. Pipelines, they're pretty much static and predefined. You don't really have a lot of wiggle room there. It's pretty much on a high level what I showed you there. Here are the sources, here are the agents, here are the destinations, that's it. And they are pretty static. You don't really have a lot of wiggle room being fancy about where and how you deploy your agents. Scale is probably one of our biggest challenges. That's true both for software and humans. By software, I obviously mean that it scales to being able to ingest billions of metrics or whatever, but also for humans. If you think about looking at the dashboard with, 20 panels, just to get an idea of what is going on there can be overwhelming. So really scale anything that you can contribute there, be it in the back end to being more efficient with storage, like the XOR from what Facebook published there for time series, or any other visualization that makes it easier for humans to consume the signals is definitely a big contribution. Timeless, we typically expect, I hesitate to call it real time because it's not really real time, but usually seconds, sub-seconds. So you would expect that if a source emits some signal, that within a second or so, you see that actually in your dashboard. Data retention, we talked about data temperature already. Big issue specifically around automation. So currently you very often have fixed, where you say like, okay, I'm gonna, for example, in our managed premises offering, you get 150 days of data, that's it, right? And then you need to work backwards from there. And querying. The one thing here really is that we're mostly dealing with time series data, and it can be a big volume. And being very efficient with the queries so that, think of you sitting, again, in front of a dashboard, because that's usually what the front end is, and you click on something and you have to wait for a minute until the query, some PrestoDB or whatever scans tens of gigabytes of data. That's not very interactive, right? You probably won't be using that tool too often. All right, and with that, we are wrapping up, and hopefully we still have some time for Q&A. So I hope I made the case that observability is indeed a very concrete data engineering application area with its specific limitations and challenges. Time series data is really dominant. So any kind of storage, any kind of processing that we're doing there, pretty much without the time series aspect is not really usable. And we definitely need more automation. That might be machine learning for detection or recommendation. That might be in the case of signal correlation. But it's really something where if you have an idea in terms of how things that you might have seen or applied in other areas can be applied to observability, please reach out to me. I'm really eager to learn. Last but not least, if you're interested in that space, I just started an early access program with Manning on cloud observability, a new book. And with that, I think we have a few minutes for Q&A left, I hope. Thank you.
Hey, wow. So I told you that we talk about observability at work a lot, and I was happy to see this from your perspective. I do have some questions here from the audience, and I just want to remind you, I see some people typing on the doc, so we have time, but just a reminder, if you have any questions, you can submit them via the Q&A doc that you can find the link on the back of your badge. So one of the first questions, Michael, is what are the hardest observability challenges from a data engineering perspective?
Right. So it's indeed what I mentioned earlier on, the scale issue. And that is that you really want to, on the one hand, you want to have all the data, everything should be queryable and so on. On the other hand, there are the costs, and for, in the real world, you're paying a lot because it's a lot of data. And at the end of the day, finding something where you could have the freshness of the data without paying as much, that would be, the holy grail, right? If someone would figure out, we see that in certain areas already. It's pretty good. Loki is a great example for logs, where you can, when you apply a different way so that you don't index, for example, the entire payload, but just the labels, that you can reduce your footprint without really limiting the expressiveness of the query. But that we need more of those, thinking differently about how do you go about things. We've been doing things in this space for many years, just essentially continuing, improving. But now we really, with these cloud native systems, we need different approaches. That's probably the biggest challenge.
Different perspectives to solve the same problems, right?
Yeah.
Okay, and then while Anonymous Buffalo is typing, we have another question. You were talking about buying versus building. And there's a question here around, it says, looking at observability solutions, what do you recommend, buy or build? And then as a follow-up to that is would you recommend according to the size or the maturity of the company or the projects at hand? Right.
So the question is there always, what do I want/need to own, right? If that's something that is a commodity thing, like think about logs that your cloud provider does for you. Maybe that's fine. Maybe you don't need, maybe you can outsource that. You can use the buy option. If that's something that's business critical to you, maybe that might be distributed tracing, maybe that might be profiles, or because of the ecosystem not being as developed as you would like, you probably want to own more of that. But again, remember the most important point being, as long as you're building on open standards, and that means you're adopting things like OpenTelemetry, or you knock on the door of your vendor and say, hey, why are you not supporting these open standards? Then the vendor has to explain themselves and say like, well, we don't think that's the right way to go, whatever. That might be an indicator why you don't want to buy at that vendor. So you really want to make sure that by using these open standards, you can essentially move around between vendors without lock-in. That's the basic idea.
Yeah, and you touched on that also as well a little bit in the very beginning. So. All right, and then let me just get back in the phone. All right, so the last question we have right now is observability currently. Wow, kind of give me a hard one. It's like a mouthful. It's observability currently contains 3 dimensions: logging, metrics, and tracing. And people adopt it in this order, as you said earlier. But which would be the milestones in a project to adopt the next dimension?
Right. So first off, it's not just these 3, right? We for a long time went around saying like, oh, these 3 pillars, but it's really 4 currently, which includes the profiles. And the point is more like, what kind of system do you have? If you do have a monolith where you know exactly, this binary or jar file, whatever is running on this machine, then, for example, distributed tracing doesn't really add too much to it, because distributed tracing is for a setup idly where you have different parts running in different places. But profiling, absolutely, right? Profiling doesn't matter if it's in a microservice or monolith. So it's more like you're looking what I usually call return on investment driven observability. So you look at what are your tasks, what do you need to invest, and that costs, instrumentation, what agents to run and patch and so on, and what is your return? How can you be quicker or debugging, or how can you release something faster or whatever? And if you work backwards from that, you get a pretty good idea. Okay, in this case, nobody can live without logs, maybe until we have distributed tracing fully deployed, metrics still being the main driver for monitoring and alerting. And as I said, profiles being a really great case for this kind of, I want to make sure that I understand where in the code I need to change things to, use less memory or whatever. So it's not as easy, but it's there's a framework there that you can apply, and the basic idea is return on investment driven observability. That's the keyword.
Okay, return on investment. My alarm.
We're running out of time.
Yeah, my alarm actually just went off. So wanted to say thank you again.
Thanks for having me.
Let's please give Michael Hausenblas a round of applause.
Thank you.